Hello and welcome to Data Science for Everyone. Today we're going to learn how to use Pandas, a powerful library in Python used in data analysis. Pandas is built on two key Python libraries, NumPy and matplotlib. NumPy provides powerful tools for working with multi-dimensional arrays, which Pandas use to store and manipulate data. Matplotlib offers strong data visualization features, and Pandas leverages these to create charts easily. When analyzing data, there are many ways to store it, but the most common format is rectangular data, also known as tabular data. Let's take an example with a very popular dataset called penguins. In this data, each row represents one penguin, that's one observation, and each column represents a property of the penguin, such as species, sex, flipper length, or body weight. Pandas is specifically designed to handle this kind of rectangular data. In Pandas, this format is called a data frame. Other programming languages have similar structures. In R, it's also called a data frame, and in SQL, it's called a table. Within a data frame, every value in a column shares the same data type. For example, all numbers or all strings or texts. However, different columns can have different data types. We'll start by importing the penguins data. The data is stored as a CSV file. We'll import the data using the read_CSV function from Pandas and store it in the penguins variable. We'll look into importing other types of data later in the video. When you first get a new dataset, the first thing you'll want to do is to explore it a bit, just to get the feel for what's inside. Pandas makes it easy with several built-in methods. One of the most commonly used methods is called head. This method shows you the first few rows of the data frame. It's useful for quickly checking the structure and contents of the data. By default, the first 5 observations are printed, but it can be changed using the n argument or parameter. Here we have set n to 6, which prints the first 6 rows. Similar to head, there is a tail method that prints the last few rows of the dataset. The info method displays the names of the columns, the data types they contain, and whether they have any missing values or not. A data frame has an attribute called shape that tells us the size of the dataset. It returns a tuple. The first number is the number of rows and the second number is the number of columns. Since shape is an attribute and not a method, you don't need parentheses when you use it. The describe method gives you a quick summary of the numeric columns in your data frame. It calculates common statistics like mean, standard deviation, and median. One of the values it shows is count, which tells you how many missing values are in each column. The describe method is great for getting a quick overview of your numeric data. Later in the video, we will learn how to calculate more specific statistics when you need more control. A data frame is made up of 3 main components, and you can access each of them using attributes. The first is called the values attribute. As the name suggests, it contains the actual data stored in 2-dimensional NumPy array. This array holds all the values in the data frame, without any labels like column names or row indexes, just the raw data. The second attribute is the columns attribute that holds the column names. The columns attribute is a special object called index object. The third attribute is the index attribute that holds the row labels, which are often just row numbers. Just like columns attribute, the index attribute is also a special object called index objects. We'll explore this in detail later in the video. One of the first things you might want to do with a dataset is reorder the rows, so the most interesting data appears at the top. You can do this by using the sort values method. Just pass in the name of the column you want to sort by. For example, if we want to sort by the body mass column of the penguins data frame, Pandas will rearrange the rows from the lightest penguin to the heaviest. At the top, we see the lightest penguin with a body mass of 2,700 grams. If you want to sort the data in the opposite direction, for example from the heaviest to the lightest, you can set the ascending argument to false in the sort values method. This flips the order putting the largest values on top of the data frame. We see that the heaviest penguin has a body mass of 6,300 grams. You can also sort by multiple columns by passing a list of column names to the sort values method. For example, we can store the column names in a list called calls and add it as the first argument of the sort values method. This will first sort the data frame by body mass and then by flipper length. If multiple penguins have the same body mass, Pandas will sort those penguins by their flipper length. To control the sort direction for each column, you can pass a list of Boolean values to the ascending argument in sort values method. Each value in the list corresponds to a column in the same order you provided them. For example, you can sort body mass in the ascending order and then the flipper length by the descending order. This gives us full control over how the data is sorted across multiple variables. Sometimes you might want to focus on just one column of your data frame. You can subset by using the name of the data frame followed by square brackets containing the column name. This will return a series containing only the values from that column. Here, we subset only the species column. To select multiple columns from a data frame, you need to use two pairs of square brackets. Here's why. The inner brackets create a list of columns you want to select. The outer bracket are used to subset the data frame using that list. This returns a new data frame with just the columns you selected. You can also store the list of column names in a variable, but most of the time, it's quicker and easier to do it all in one line. There are many ways to select specific rows from a dataset. One of the most common methods is using a logical condition to filter the data. For example, let's find all the penguins that are heavier than 3000 grams. This creates a list of true or false values, one for each row based on whether the condition is met. We can place the same logical condition inside square brackets to filter the rows we want. This will return a data frame of only the penguins whose body mass is greater than 3000 grams. We can also use the same logical subsetting on categorical columns as well. Here I am filtering out those observations that contain only the Adélie penguins. To filter rows based on multiple conditions, you can combine them using logical operators like the AND operator shown here. This means only the rows that meet both conditions will be included. You can also write this in a single line of code, but make sure to wrap each condition in parentheses. If you want to filter for multiple values in a categorical column, the easiest way is to use the isin method. This method takes a list of values to match. In this example, we want to filter out penguins living in Bisco and Dream Islands, and then use the condition to filter the dataset. There are several ways to describe the process of adding new columns to a data frame. It's often called mutating, transforming, or feature engineering. For example, let's say we want to add a new column that shows the penguin's mass in kilograms instead of grams. On the left side of the equal sign, we use square brackets to name the new column. On the right side, we write the calculation. After running this, both the original column and the new one appear in the data frame. A quick detour before I move on. Looking at the YouTube data, I can see that only 9.3% of you have subscribed. If you have enjoyed the video and learned something new, please consider liking this video and subscribing. Now let's learn how to compute summary statistics in Pandas. One of the most common summary statistics for numeric data is the mean. It gives you a sense of the center of the data. To calculate mean of a column, you select the column using square brackets and then use the mean method. There are many other summary statistics you can compute as well, like median, mode, maximum, minimum, variance, and standard deviation. You can also calculate totals with sum or find specific percentiles using the quantile method. The aggregate method or AG lets you calculate multiple summary statistics at once. In this example, we select the column we want the summary of and call the AG method with names of the summary functions as a list. Calling the ag method on the body mass column with mean and median gives us the values for that column. We can use the ag method to compute summary statistics for multiple columns as well. To do this, we place those columns in a list and call the ag method with the intended summary functions. The ag method lets you calculate custom summary statistics as well. In this example, we define two functions called PCT25 and PCT75 that calculates the 25th and 75th percentile of a data frame column. Then we select the body mass column and use the ag method, passing in our custom functions. This gives us the 25th and 75th percentile of the penguin's body mass. Pandas also lets us calculate cumulative statistics, like cumulative sum. When we call the cumSum method on a column, it doesn't just return just one number. It gives us a running total for each row. The first value is just the first penguin's body mass. The second value is the sum of the first and second penguin's body mass. The third value adds the first three and so on. The final number is the total body mass of all the penguins. Pandas also has methods for other cumulative statistics such as cumulative maximum, cumulative minimum, and the cumulative product. These all return the entire column of a data frame rather than a single number. Sometimes the data has duplicate observations which interfere with downstream data analysis. To remove duplicates, we can use the drop duplicates method. It takes a subset argument which tells Pandas which column to check for duplicates. In this case, the species column. Now we have a data frame where each penguin species appears only once. We can also subset with two or more columns. In this case, I have dropped duplicated values from both species and island columns. To count the penguins of each species, we subset the species column and use the value counts method to count the individual penguins in each species. Adding sort equals to true, we can sort the data with the highest species counts on the top. The normalize argument can be used to turn the counts into proportions of the total. Here we can see that 44% of the penguin species are Adelie penguins. Now let's see how we can use Pandas to get summary statistics. While calculating summary statistics for the entire columns is useful, we can learn even more by summarizing the data within groups. To that end, we can use the group by method. For example, we can group by the species column, select the body mass column, and call mean. This gives us the average body masses for each penguin species. We can compute several summary statistics at once by grouping and then calling a list of the summary functions inside the ag method. Here, we are summarizing by mean, maximum, and minimum on the body mass column while grouping by species. We can write our own summary functions and use them as well. Here, I wrote two functions, PCT25 and PCT75, each of which computes the 25th and 75th percentile respectively. We can place these functions in the list of the summary functions and call them using the ag method. We can also group by multiple columns and calculate summary statistics at once. Here, we group by species and sex, select the body mass and flipper length column, and calculate several summary statistics. This gives us the stats of each species and sex of penguins for the two columns we selected. Pivot tables are another way to calculate grouped summary statistics. If you have ever used a spreadsheet, you have probably worked with pivot tables before. Let's see how to create them in Pandas. Previously, we grouped penguins by species and calculated their average body masses. We can do the same thing using pivot table method in Pandas. The values argument specifies the column you want to summarize, and the index argument is the column you want to group by. By default, pivot table calculates the mean for each group. If you want to use a different summary statistic, you can pass a function to the agfunc argument. For example, to calculate the median body mass for each penguin species, we can use NumPy's median function with agfunc. To get multiple summary statistics at a time, we can pass a list of functions to the agfunc argument. Here we get the mean and median for each penguin species. Earlier we calculated the average mass of penguins grouped by both species and sex. We can do the same thing using pivot table method. To group by two variables, just pass the second one to the columns argument. The result may look a bit different from before, but the numbers are the same. In some cases, pivot tables will produce nans or not a number as shown here. This can be fixed by using the fill value argument. Let me demonstrate. As you can see, here we have set the fill value argument to 0, which replaces all nans with zeros. If we set margins argument to true, the pivot table will include an extra row and an extra column that shows the mean for each group, excluding any missing values that were filled in with zeros. For example, in the last row, we see the average weight of female and male penguins. In the last column, we see the average weights for 3 different species of penguins. The value in the bottom right corner shows the overall average weight of all the penguins in the dataset. Using margins equals to true gives us a quick summary of multiple levels by each variable, by combinations of variables, and for the entire dataset. Previously, we saw that Pandas data frames are composed of 3 parts: a NumPy array for the data, and 2 indexes to store the row and the columns. We looked at the columns and index attributes, which are special objects called index objects. The .columns attribute contains the index object of the column names, and the .index attribute contains the index object of the row numbers. We can move a column from the main part of the data frame into the index. This process is called setting an index, and it's done using the setIndex method. After doing this, you'll notice a slight change in the output. The column row ID is now a part of the index. We can use the resetIndex method to remove any indexes. As you can see, we have removed the row IDs and it is now a regular column in the data frame. There's an argument in resetIndex method called drop. Setting drop equals to true removes the index columns from the data frame entirely. So why even bother using indexes? Well, they actually make your code a lot cleaner, especially when you are trying to filter data. Let's say you want to pull out row IDs 1 to 3. Without using index, the code can get a bit messy for something that seems so simple. But if you have already set the row IDs as index, it's way easier. You can just use the loc method and pass in the IDs you're looking for. That's it, much more straightforward. One thing to remember is that indexes doesn't need to be unique. There can be duplicate indexes. If you subset with loc on duplicated indexes, all the rows that match will be returned. Now let's look at hierarchical indexing. You can create a hierarchical or multi-level index in your data frame by passing a list of column names to the setIndex method. For example, using both row ID and species will give you a hierarchical index. This means that species is grouped under each row ID, forming a structure where one level is nested inside the other. To filter rows based on the outer level of a hierarchical index, you can use the loc method with a list of index values. For example, if you pass a list containing 1, 2, 3, you'll get all the rows that belong to those observations. To filter based on the inner levels of a hierarchical index, you need to use a list of tuples with loc. Each tuple should match all levels of the index. For instance, 1 and adeli will return only the rows where the row ID is 1 and the species is adeli. Any rows that don't match both conditions won't be included. Previously, we learned how to sort rows using sort values method. Now, if you want to sort by index instead, you can use the sort index method. By default, it sorts all levels of the index, from the outermost to the innermost in ascending order. You can control the sorting by passing lists to the level and ascending arguments as shown here. Now let's move on to slicing. Slicing is a common technique used to select consecutive elements in objects in Python. Let's take an example. We'll first set index on the row ID and species column of the penguins data frame. For slicing data frames, it's always a good idea to sort the data frame first using the sort index method. Now, to select a range of rows using the outer level of an index, we use the loc method and provide the starting and ending index values separated by a colon. There are two key differences of slicing a regular list from a data frame we are demonstrating here. First, instead of using row numbers, you can use the actual index labels. Second, the end value you specify is included in the result. For example, in this case, the row labeled 5 is part of the output. The same technique will not work when we want to slice using the inner index. To slice using the inner index, we need to pass the first and last positions as tuples. In this example, the first element of the tuple is 1 and the second element of a tuple is adili. Since data frames are two-dimensional, you can also slice columns in addition to rows. To do this, use loc with two arguments. The simplest case is when you want to keep all the rows but select only certain columns. In this case, pass a colon as the first argument to indicate all rows, just like in list slicing. Then, for the second argument, provide the starting and ending column names to define the range you want to extract. In this example, we are slicing out the first 4 columns. If you want to slice both rows and columns, in the first argument you can specify the first and last index as tuples, as I have demonstrated earlier. Previously, we looked at how to create pivot tables. Now let's look at how we can slice pivot tables and perform computations as well. Let's look at how to use the pivot table method again. Inside the pivot table, start by passing the name of the column that contains the values you want to summarize. Then use the index argument to specify which columns should be used to group the data into rows. Similarly, use the columns argument to define how the data should be grouped into columns. By default, pivot table will calculate the mean for each group. Pivot tables are just regular data frames with their indexes already sorted. That means everything we have learned so far still applies. This makes them perfect for using loc along with slicing to extract specific sections. It's a powerful way to subset your pivot table and focus on just the data you need. In this example, we use the loc method and slice using the species names. When we calculate summary statistics like mean on a data frame, we can use the axis argument to control the direction. By default, it's set to index, which means that the calculation runs across rows. In this example, the mean is calculated for the penguin's body masses. This is the same result you'd get even if you didn't specify the axis argument at all. To calculate a summary statistic for each row instead of each column, set the axis argument to columns. In this example, we are calculating the average body masses for each species of penguins. Sometimes the data frame might have missing values, and it's important to know how to deal with them. Real-world data is rarely perfect. Let's see how to deal with missing values next. In Pandas, missing values are shown as nan, which stands for not a number. When you first load a data frame, it's a good idea to check if there are any missing values and how many. That's where the isna method comes in. It returns a Boolean value for each cell, showing whether it's missing or not. But when you are working with large dataset, this raw output can be overwhelming. When we use isna method followed by any method, it checks each column and returns a single result per column. The output tells us which column contains any missing values. In this case, we can see that bill length, bill depth, flipper length, body mass, and sex contains missing values. Because adding Boolean values counts how many are true, we can use sum method along with the isna method to find out how many missing values are there in each column. We can take these counts and create a bar plot to visualize the missing data in the dataset. I have used the matplotlib plotting library in Python to create a bar plot. These kind of plots are more useful when multiple columns have missing values. As we can see, the sex column has the most values missing in the penguins data frame. If you want to learn more about how to use matplotlib for plotting, I have already made a detailed video. The link is in the description. Now that we have identified the missing data, what are our options for handling it? One way to deal with missing values is to remove any rows that contain them using the dropna method. But this isn't always the best choice if there are many missing values. You could end up losing a large portion of your data. A better approach might be to replace the missing values with a specific value using the fillna method. This method fills in all the nans with the value you provide. Here we are replacing all the missing values with 0. There are more advanced methods of handling missing values, and I'll discuss these methods in a later video. With that, we come to the last part of this tutorial on pandas. Here we'll look at how to create and export data frames. There are two ways to make a pandas data frame. One way is to store several dictionaries in a list. Let's look at this example. We have created a list called list of dict, and inside we have stored two dictionaries. A dictionary has a key and a value pair. In this case, the name is the key and the values are Alex or Lucy. Same goes for sex and age. Once we have created this list, we can call the dataframe method to create a pandas data frame. The other way is to make dictionaries of multiple lists. Let's look at this example. We have created a dictionary called dict of list, and inside we have stored three lists: name, sex, and age with their corresponding values. Once we have created this dictionary, we can call the dataframe method to create a pandas data frame. Lastly, to convert a data frame to a CSV or comma-separated value file, we can use the ._CSV method and pass in a new file path. It will save the data frame as a CSV file in the path we provided. In this case, the file path is just the file name, and it will be saved in the current directory. That brings us to an end of the video on how to use pandas. If you like this video, please subscribe to my channel. I plan to bring new videos every week. Also, please like the video if you have learned from it, and comment on what else you want me to cover. Thank you and happy coding!